Hello, everybody. Welcome back to class. I'm glad you're here. I feel like my thing is a little bit, I don't know. The second I started moving the camera, half the class left. Woot. So yeah, say hello if you're here. Hola, Jared. Welcome back. Hope everybody had a good weekend. Hello, Reagan. Hello, Jonathan. Jax, good to see you. Just finished watching the Taiwan baseball game. Cool, that sounds fun. I've been watching Backyard Baseball 2001 on Twitch lately. Bonjour, Johannes. Nice to see you joining Calc and Linear today. Navik, hello. You too as well. Did the double today. Subscriber count is climbing. Jared, you know that's my big focus. Got to hit that 1,000 mark. Then I'll calm down a bit. But yeah, putting in the grind every day to get that subscriber count up. So we'll get started in about a minute. Why does Navik have a wrench? He's a moderator, so he can ban trolls if they get out of hand. So careful with your comments. Hello, Turner. Welcome back. All right, well, it's 10 o'clock. So you know what that means? It's time for the simultaneous sip, our second to last one of the semester. So if you'd like to join in on the simultaneous sip, you don't need much. You just need something to sip on. You can do so now. Yeah, so let me see in the chat if anybody joined in on today's sip. I hope tomorrow we get like 30 people joining. But seeing as the attendance has fallen to record lows, I don't anticipate seeing 30 people. Slurp. You should ban people that don't smash the like button. Yeah, that is a great idea. Okay. Yeah, so we're done with material. I'm sorry if you wanted to learn about, I think I just cut out there for a second. I'm sorry if you wanted to learn about Newton's method or the area between two curves. Tough luck. We lost a week of class. Okay. You'll start Calc 2. If you take Calc 2, which I hope some of you are, you'll start by reviewing a lot of the applications to integrals. You'll probably never see Newton's method again in your life. So, yeah. So the plan for today, so there's one WebAssign that's actually due tonight. That's the chain rule the use substitution WebAssign. 5.1 is also due tonight, but that's extra credit. Okay, so like people should be getting like 110% for their overall WebAssign average, and that's fine. But yeah, so get those done tonight. And then yeah, try the 5.1. It's easy stuff. But I obviously am not going to go over it. Okay. So yeah, the plan for today and tomorrow. Correct, Jax. Those won't be in the final. 5.1 and Newton's method are not in the final. Okay, I'll get to your question in a second. Let me finish my thoughts. The plan for today and tomorrow is just any question you want to go over, we're going to go over. Okay, so just type it in the chat if there's a specific question you want to cover or just a topic you want to cover. I have the book, so I can find a good question. We could do those. Jared said, there are some optional questions on WebAssign, right? Yes. I put in an email the list of the optional ones for U substitution. There's quite a few of them, like 5 maybe. And then 5.1 is entirely optional. Okay, so in the chat, let me know if there's any specific questions you want to go over. Could even be from the tests that we just took. You guys got absolutely crushed. I give one. Now I'm teasing you. I'm not trying to be mean. I give one question that you haven't seen like a literal identical question to, and it crushes you. Crushes you guys. Come on. We could start with that question if you want, unless it's too soon. I mean, maybe that reflects on me. Are we? 5 was an L. Yeah, that's the one I'm talking about. Yeah, can we go over 5? Yeah, I'm going to do this, and you guys are all going to be kicking yourself when you see how simple it is. Okay, so let's do 5. It was a 3-parter. A lot of you got part C, which was the one that so out of the 24 points, part C was worth 12 of the points. So that was the question you've seen before. A and B you have not, but let's see if we could figure this out. So this is number 5 on the test. And I'll post the answers to the test today. I just haven't gotten to it. So A was the integral from 0 to 1 of the derivative of the square root of 1 plus x squared dx. Now, what I am happy with, so I knew this was going to be the hardest question, and I intentionally gave a function that our class, Calc 1 students, don't know how to integrate. But Calc 2 students do know how to integrate. So I am happy with the honesty. I was very impressed with the overall academic honesty for this question, because this is not too hard to integrate with either an integral table or trig substitution, but yeah. Okay, so maybe there's some positives that came out of this. All right, that was A. B was the derivative of the integral from 0 to 1 of the square root of 1 plus x squared dx. And then C was the derivative from x to 1 of the square root of 1 plus t squared dt, right? So we agree that C at least is something we've seen before. Okay, does anybody in the comments, I know a few of you got this right. Does anybody in the comments want to say how they did A? Or if, since it's been a few days since you took it, has it come to you? And I know whenever I would take a test in college, it's all I would think about for the rest of my life. So yeah. So have any of you thought about this question at all? Any ideas of how we could solve A? The integral from 0 to 1 of the derivative of the square root of 1 plus x squared dx. No thoughts? How about give me a question mark face or some sort of confused face emoji if you aren't sure, just so I can know that the chat, just so I know the chat is updating. Okay, Jax has an idea. For A, the integral of a derivative. Okay, yeah, so we have some confusion. Jax even puts an I think at the end, so he's 100% confident. Well, let's see. Let's read what he says. The integral of a derivative is the function itself. Yeah, that's like the miracle of calculus. The fundamental theorem of calculus says that the integral of a derivative is the function itself. So what we do is we evaluate at 1, we evaluate at 0, and we take the difference. Yeah, Brant, what you said also is the right idea. Like the integral and the derivative, when we take it in this order, cancel each other out. Yeah, so this, for A, it's just square root of 1 plus 1 minus square root of 1 plus 0, which is square root of 2 minus 1. Okay, so that's A. Okay, B. It says the derivative, you're going to kick yourself after this one. The derivative of the integral from 0 to 1 of the square root of 1 plus x squared dx. Okay? Oh, Turner looks sick. I'm fuming. Okay. The integral from 0 to 1 of this function is what? It is a number. Okay? It's the area under the curve from 0 to 1. Okay? It's a number. Part B feels like a proof, honestly. No, it's less than that. The integral from 0 to 1 of any function, so a definite integral of a function is a number. Okay? It's just a number, not a function. It's a constant. What is the derivative of a constant? Right? That's what it's asking. Find the derivative of a constant. It's 0. Okay? We don't know what this number is, and we don't care what the number is. The derivative of a constant is equal to 0. Okay, and then for C, well, this one went over better than the other ones. Right, so what do? And the thing, now I feel like I'm just rubbing salt in the wounds. Like, we could have used this. You could use the same techniques. You could use the same techniques as we used here. Typically, how can you just say that it's a constant? Right? A definite integral is always just a number. If you evaluate a definite integral, it's just going to be a number. We don't care what the number is. It does. So, right, if you evaluate this definite integral, you would find the antiderivative of 1 plus x squared. That's some function. Evaluate at 1, that's a number. Subtract off when you evaluate at 0. That's also just a number. So subtract off 2 numbers, you're left with a number, and then taking the derivative of that number will give us 0. If you're not happy with that answer, what we could have done, I know we're pretty happy with taking derivatives of these types of functions. You could have broken it up along the way at, let's say, x, and then had 2 questions that were similar to this. Right, this integral, a definite integral is just a number. It's the net area under the curve. And in this case, since it's always going to be positive numbers, it's the area under the curve. Okay, so for this last one, again, what we do is we flip the integral. We switch the order of we switch our bounds. So we have x up top. And then we take the derivative. Using the fundamental theorem of calculus part 1, we know that this is negative the square root of 1 plus x squared. Any thoughts about question 5? Or are there any other questions we want to go over? I feel like I pulled a little bit of a fast one on you guys with this question. That's part of the reason why I am letting the final replace your lowest test. If we were in person, I wouldn't feel as bad. But this whole online thing, I'm going to probably try to avoid the fast ones now. Jared is sad. Are you sad about this question? Or yeah. Yeah, so let me know. Are there any other questions we want to go over? So does the final count twice if it replaces the test? I mean, kind of, right? The final right now is 25%. But if it replaces your lowest test, then it will be 35%. Yes, but I'm gracious for your generosity. No problem. Number 7 from the last exam. So this most recent one, the one. Rena, can you say exam 2 or exam 3? And then maybe type the question. Exam 3. Oh, I have this one. I have this written out, actually. 7. All right, good. So you guys like 7. So it's the integral from 0 to pi over 2. So it's the integral from 0 to pi over 2 of cosine of x over the square root of 1 plus 2 sine of x dx. Do we have any thoughts of how we could get started? Let u equal 1 plus 2 sine of x. Use substitution. Yes. So let's try that. Okay, so that means du is what? Du would be what? And then my next question is, what do we do about the bounds? Yeah, so du is 2 cosine of x. Sorry, 2 cosine of x dx. And we have, in our expression here, we have a cosine of x dx. We don't have a 2, so let's just Move that 2 over. And the bounds? U of pi over 2 is equal to 1 plus 2, which is 3. Not sure why I wrote these in this order, but 1 plus 0 is 1. All right, so our integral we could rewrite as the integral from 1 to 3. We have a 1/2 on the outside. All right, definitely looks simpler. But how do we solve this? How do we integrate this? Yeah, we'll make it u to the negative 1/2, and then this is straightforward. One-half divided by 1/2 is just 1. So it's u to the 1/2, evaluated at 1 and 3, which is square root of 3 minus 1. Good. So what else you guys want to talk about? I don't know if you all saw this, but I made an epic YouTube video for my linear algebra class. Rumor has it there's an epic YouTube video coming out from my calculus class, but I have to make it still. So keep your eyes open for that. It's going to go viral. I'm sensing it. It hasn't happened yet, but this one's going viral. Can we do limits? Yes. What kind of limits? Will early stuff or derivative, limit definition of derivative, or what type of limits? Integral limits and integrals? Early stuff. Yeah, let's do an early one. And then Jack said, could you do a problem where you have a piecewise function and have to find discontinuities? Yeah, we could probably do 2 for 1, right? Try to get a question that does both. Okay, so we want limit stuff. Will, would you rather have limits to infinity or limits to a number? Number. All right. See if we can find a good one. Okay, so this is gonna be both answering Jax's question and Will's question. Okay. I don't like that. Okay, so basically we want to find where the function is continuous or discontinuous. Okay, and so it's going to involve some limits. Okay, so we have this piecewise function. We have a piecewise function, and we want to figure out if there's any discontinuities. So does anybody remember how we do this? And if that's not the type of question you're looking for, then I'll write another one, Will. But I'll do that next. Jack said, aren't there 3 conditions for continuity? Yeah. So remember, we're going to check at each of these spots where the rule changes. Okay, so we're going to check at f equals 0 and x equals 1. Sorry, at x equals 0 and x equals 1, we need the limit as x goes to a of f of x exists. Okay, we need this to hold. We need f of a exists. And then we need these values to be the same. Right, so we want to check all 3 of these conditions. Okay, so let's just do that and we only have to do it since these are all continuous functions, right? Polynomials are continuous functions. We only have to check when the rules switch. So at 0 and at 1. Okay, and so when we're evaluating the limit as x goes to 0, we have to do a limit from the left and a limit from the right. Okay, so how do we evaluate the limit as x goes to 0 from the left of our function? What is this value? Yeah, it's 2, right? So we would use the top rule, right? Because we're taking values slightly less than 0. And so it's 0 plus 2 equals 2. For the limit to exist, we need to check both the limit from the left and from the right. So let's do the limit as x goes to 0 from the right. From the right, we would use this middle rule. So it'd be 2 times 0 squared And so since the limit from the left is not equal to the limit from the right, the limit doesn't exist. Okay, and we'll do the same thing at x equals 1. It's too bad about this question because I'm going to switch this. Okay, this used to be a 2. I'm going to make it a 3 because I don't want it to be discontinuous at both spots. Okay, so we'll do the limit as x goes to 1 from the left. We'd use the middle rule. So it's 2 times 1 squared, which is 2. The limit as x goes to 1 from the right is equal to 3 minus 1, which is also 2. See, that's why I changed the number so it could be the same. So we could conclude that the limit as x goes to 1 of f of x is equal to 2. Okay, so that's the first condition. The limit as x goes to 1 of f of x exists. We showed it was 2. All right, the next part is f of 1 equals, well, what does f of 1 equal? Or which function do we use to check f of 1? Which part? Yeah, it's equal to 2, and you also use the second function, so I'm not sure what those answers, what part they were saying, but it's either way, they're right. So f of 1 is, now, so you wouldn't use the last part, right? Because you check the middle part has x is less than or equal to 1. This last part only has greater than 1. So 1 is not greater than 1. 1 is less than or equal to 1. Yeah, so we use the middle part. And then we check, is this number the same as this number? It is, so f is continuous at 1. And in fact, it's continuous everywhere except for at 0. So f is continuous on negative infinity to 0, union 0 to infinity. Another way you could write this is when x doesn't equal 0. Again, I'm not too particular with notation. Okay, Will, I don't know if that really answered the type of question you wanted, so I found a good, like a pure limit question we could look at. I thought maybe I'd get 2 birds with 1 stone with this question, but I don't think the limits were challenging enough. Okay. This is just a good old-fashioned limit question. Evaluate the limit as x goes to negative 4 of the square root of x squared plus 9 minus 5 over x plus 4. Those are 4s? Yeah. And then this is a 9. Okay, how do we go about solving this? This doesn't, this question is not just aimed at Will. Anybody here? How would we go about solving this question? And if you're unsure, maybe put some good old conjugates. Yeah, could not say it any better myself. Yeah, so even though this is not like multiply by conjugate, good. Yeah. Whenever you have these square roots, conjugate, makes things a lot cleaner. Okay, so let's multiply by the conjugate. Okay, and so our limit, and another good strategy is, like with the denominator, there's no need to kind of multiply this out. The numerator will multiply out because that's the whole point of multiplying to the conjugate, is to clean up our numerator. But the denominator we could just leave as a product. So our numerator is x squared plus 9 minus 25. And our denominator is x plus 4 square root of x squared plus 9 plus 5. Okay, and I'm just going to write this as x squared minus 16. All right, where do we go from here? Again, we could try, a good idea would be to try to plug in x equals -4, but you'd get 0 over 0 again. So it didn't really help. It did help, but we got one more step to do. Factor the top. Yeah. The top becomes x minus 4 times x plus 4. This is why we didn't distribute out the denominator. Those guys cancel, and then we could plug in -4. So it's -8 over, and then our denominator would be 5 plus 5, so 10. Yeah, so if you see a limit question with a square root, good idea is to remember the conjugate. All right, we still got 15 minutes or so. What else should we look at? Has anybody looked at the final exam packet that's posted on Canvas? I believe I posted it there. The not so fun limit definition of derivative. I'm not sure what the not so fun limit definition of derivative, but we could just do a limit definition of derivative question. Yeah, so I'll just make one up. Or Jax, is there a particular type you want to look at? What did we basically did it with polynomials, rational functions, and radical functions, square roots. So we just did a square root question. So maybe let's not do the square roots. Would you prefer rational function or, yeah, okay, rational, good. Okay, I'm just gonna make one up. How's this? 2x over x plus 1. Let's find the derivative using the limit definition of the derivative. Okay, I'm not even going to ask the chat. Actually, this is what I'm going to ask you to do. Say out loud, I can't hear you, but it's good practice. Say out loud what the limit definition of the derivative is. because it's too much to type in chat. But so you're still, kind of participating in class. Follow along with what I'm saying. It's f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. All right, did anybody actually say that out loud? I did. Okay, so this is equal to the limit as h goes to 0 of 2x times x plus h over x plus h plus 1 minus 2x over x plus 1 all over h. What do we do with this? How do we deal with this? What we got here? Common denominator. Yep, that's a good idea. So this is equal to the limit as h goes to 0. I'm going to pull this h from the denominator and write it as a 1 over h. Yeah, so common denominator is the strategy here. A conjugate's not going to help us out too much with these types of questions. Those are better for the square roots. Yeah, so when you have a fraction over a fraction, common denominator is usually the best strategy. So this is the limit as h goes to 0 of 1 over h times, our numerator is 2x squared plus 2xh plus 2x plus 2h minus 2x squared minus 2xh minus 2x. Ooh. All right, and our denominator stays the same. Okay, and a lot of terms cancel. I'm not going to actually physically cancel them out because the board's going to get too messy. But you could do that on your own paper. Okay, the 2x squared canceled, the 2xh canceled, and the 2x canceled. We're left with a 2h in our numerator. And now we have an h over an h. We could cancel those out, and I'll actually cancel these out. Okay, so what do we do now? What's our last step? How do we finish this? Oh, sorry, factor out an h. I might cancel out. Yeah, good. So I did that. What's left? What's left? Plug in 0. Yep, that's how we know we're done. we get 2 over x plus 1 squared. All right, now here's the question for you. We just spent all this time doing our answer. How do we check our answer? Graph it? That'd be tough. That would be tough to graph. Okay, let's say quotient rule. Yeah, for clarity of writing. That's true. Yeah, but the way we could check our answers, we could just use the quotient rule. Right, so f prime of x is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Which is 2x plus 2 minus 2x over x plus 1 squared, which is 2 over x plus 1 squared. Okay, so we did it right. But yeah, I think it's important. We have all these shortcuts that we've learned. So this is true not just for derivatives, but this is true for the integrals with limits also. Once you work out the limit, you get your solution using limit techniques, check your answer with the shortcuts. Because that took us a minute. So we probably have time for one quick one. Before we have to end. Well, we have to know the beta epsilon. I think you mean epsilon delta definition of the limit? No. No. Don't worry about that. Yeah, no epsilon delta definition of the limit. If you go on to analysis, you'll see enough of that. All right, Jonathan says, can you go over a trig function that goes to a crazy high exponential power? Yeah, sure. Let's say we had, okay, and this is good because it's quick. So let's say we wanted to say find f of x is equal to cosine of x or cosine of 2x. Find the 100th. Find the 100th derivative of x, of f. All right, and since we're kind of short on time, I'll just walk us through. Well, let's think. Let's just take a few derivatives, see if we could find a pattern. So f prime of x is -2 sine of 2x. That's the chain rule. F double prime is equal to -4 cosine of 2x. Again, we're going to do the chain rule every time. F triple prime is equal to 8 sine of 2x. And the fourth derivative is equal to 16 cosine of 2x. And we're kind of back where we started, except with a factor of 16 out front. And maybe you could see the pattern. Each time this leading coefficient is getting multiplied by a factor of 2. Okay, so for the 100th derivative, of cosine of 2x, we're going to have a 2 to the 100th power. right? Each time we multiply by a factor of 2. So we'll have a 2 raised to the 100th as our leading coefficient. And then we got to figure out where in the rotation, where in the cycle is 100. And remember, the way we did that was you divide 100 by 4 and you look at its remainder. Okay, so the 100th derivative of cosine is going to be the same as, well, 100 divided by 4 is 0. So it's going to be the same as the 0th derivative, which is the function we started with. So it's 2 to the 100th cosine of 2x. You know, just to continue the pattern, the 101st derivative would be 2 to the 101 times negative sine of 2x. You kind of figure out the pattern from there. All right. That seems like a good place to stop. So tomorrow we'll just do the same thing. Keep your eyes open on YouTube. I'm hoping to have this epic video finished today. It's going to be a good one, I hope. The thumbnail is good, at least. No, can't believe class is already over. Yep. So remember, smash the living daylights out of that like button before you get out of here. And yeah, start looking over the material so we could have other questions for tomorrow. The final is May 4th. So that's Monday. It's coming up. So I'll stay around and answer any last minute questions. May the 4th be with you. Good luck, y'all. A. Have a good afternoon / evening wherever you are. Thanks. Yeah, it's still actually the morning over here in North Carolina. See you, Turner. Thanks for coming to class. I have some questions, but they're not about presenting the math, than the math itself. Would you have time to chat? Quickly, what's the question? If not, DM me on Reddit. I'm assuming you saw Coffee and Calculus with Dr. W Reddit account. Or comment on this video on YouTube, and then I could respond. Do you have your own subreddit? No, but I kind of took over the Learn Math subreddit. My friends love your videos. Johannes, I'm happy to hear that. Hopefully they're subscribers. Are they in calculus or are they in linear algebra? How to best self-teach math? I recommend just doing a bunch of practice problems, and there's Khan Academy is a good place to start if you need more details. Three Blue, 1 Brown has a lot of good videos. Oh, syntax and stuff? Yeah, I would go videos because they speak it out. Calc, your friend is in Calc. Cool. My friend Dr. Payam has a lot of good videos. But yeah, I'll answer any questions if you DM me in Reddit or just comment on YouTube videos. I'm always replying to those. I got nothing else going on. Johannes, I'm glad your friends find the videos helpful. All right, I'm going to end this stream. But Michael, if you have questions, just not on this chat. Wait until this video is published so then I can respond to them. Does that work? All right. Bye-bye.